Hello there and welcome back. You've seen the value scanner, you've seen the pointer map, you've seen the disassembler, and you've also seen the first two merged in together. What you didn't see is the disassembly part merged together. And this is exactly what we're going to do in this episode. What we're gonna do today is gonna make our value scanner, our whole project, so much more practical because it is going to provide us the exact results we need. And I'm gonna show you how to do that. So let's get started. Also, well, of course, before we start, don't forget to overflow that like button. It helps me absolutely tremendously. My goal is to get to negative 2.147 billion likes, but it first has to go over 2 billion likes, so please help me get there. I'll be forever grateful for you. Thank you. Now, let's get started. So, what we have here is our main function. What we want to do is merge the Disassembler module with this scanning part, where we essentially scan for stuff. And what we want to do is essentially pass in the list of the global variables that are collected right here. Once they're collected, we're gonna just use them as inputs, as starting points for the pointer map. And it's very simple to do it. We're going to, first of all, disable global collection right here. It's not needed. We will delete that later on. But what we're gonna do is add a function for globals, and it will be G. And it's going to be very simple. It's going to be disasm.reset. And I just remembered, I absolutely forgot to set up the Vim plugin. Sorry, Dashi. I'll set it up right after the video. And we just collect the globals, as simple as that. We're going to print out the number of global variables we've got. It's going to be global variables found. And it's just going to be disasm.map.len, global variable references. Because it doesn't give the global variables. Instead, it gives us the references to them. So it could be many addresses pointing to one single variable. So it's a very fine distinction, which we'll tackle in the next step. Now, we need to pass an argument in the format. We want to have like a mandatory option. Do you want to use the disassembler or all of the variables? So it will be a string essentially. And what we're gonna do here is in the matches, right here in the matches, we're gonna just check that thing. It's gonna be right here. First of all, some use disassembler, and we're gonna check if use the equals I, yes. If it's equal yes, then we use that, else we go to this branch, then else we just go to this regular old code and we remove the semicolon, add a semicolon here, and right here what we're gonna do, we're gonna check first of all if the globals are initialized. So if disasm.map is empty, if it's empty, we are going to call disasm.collect globals, and we pass in the process. Else, we're gonna call a function which takes in the globals in, essentially. And we want the same function, like find matches, but with one additional argument, and that is a list of addresses to start from. So it will be pointer map and find matches, I don't know, ADRs, and it will have the same L range, upper range, max depth, value scanner dot matches, and one last thing, it's going to be disasm dot map dot values. The key is the instruction address, and the value is that value it's pointing at. So we're going to use values. And we need to copy them because we want to have an iterator of addresses themselves, not of references to addresses. And that should be it. And what we're going to do is we're going to define this function. And the definition is going to be actually, we're going to turn find matches into find matches ADRs, and it's going to take ADRs. It's going to be an implementation of iterator, type equals address. And what we do here is we replace self.map.keys with ADDRs, and this is no longer a reference. And now we take the same function. This function is going to have the same signature, essentially the same signature, and no addresses. What it's going to do is call self.find matches ADDRs, and it's going to pass L range, upper range, max depth, search for, and self.map.keys dot copied. And this is a regular old function. And once you have that, it's very simple. Once you have that, once you have this right here, you're gonna have run release item. It's not type, it's item. We need to change this, do these. And one more thing, and right here, this one more mistake. And that's it. Essentially, once you run it, we're gonna search for right here the money value. I have it right here at 96. Oops, I64 96. We update it to 95. And we're gonna do OS yes 0325. And we got our matches essentially. What do we have here? So we ran the first it took a bit of while. Let me rerun it. OSY 0325. As you can see, this time it was instant. And what do we have here? We have this 4F8030. We have right here 4F8040 actually. Plus 32 goes to there, plus that, and you've got your money value right here. Right here we have 4F8040 plus 16 goes there. This is actually our thing we're looking for. But another thing you notice is that there are duplicates. You've got this, you've got this, you've got this. They are the same. And this is what I talked about of keys versus values. The disassembler stores references to the global variables, not the global variables themselves. We might want to improve that later on to just return a non-duplicate list of global variables. But for now, we need to do that ourselves. And for that, it's going to be extremely simple, actually. We're going to use a structure called B-tree set. So it will be right here. And B-tree set is like B-tree map, but it just holds a non-duplicate list of values. Like it's a B-tree map to nothing. That's the type dev. But we're just gonna iterate through the B-tree set and we're gonna just create let set. It's gonna be B-tree set of address, but we don't need to specify it. It's going to be disasm.map.values .copied.collect. It's a long line, but what we're gonna do here, we're gonna pass set.intoIterator. And now, once we run, what you should have, I6495, we've got 6 matches, we updated 94, you've got 1 single match, and we're just gonna do OS yes 0325. And now what we've got are 3 matches. And it's, well, rather simple. You've got the 4F8030, 4F8038, 4F8040. So probably there are like 3 different like global variables right next to each other. And we're interested into, of course, 4F8040. And it just goes right here. So you would you might want to do some kind of post filtering to eliminate the first duplicates, find out which has the lowest offset. But frankly, I think that's absolutely enough, because you're gonna have up to this offset, and you can just handpick it for now, and it's gonna be this one. Essentially, this is it. Now, what we have is our offset scanner. Offset tree, we linked it up together with the disassembly module. It makes it even more flexible. Now, it doesn't make it more flexible, it makes it more useful, because beforehand, if we actually pass OS and 0.32.5, you've got a ton of matches, which is very cool. You've got matches, but lots of them are not even useful at all because they start from the heap, and we don't care about that. So yeah, what we did, we added in the disassembler, which makes it more useful, which allows us to find what we're actually looking for, not just what we find. So I'd say it's really cool. Let's do some cleanup right here, and we add a help OS. Yes, no. It's gonna be a default of no, and we also have a filter right here. Now if we run it, we have a OS, we have usage right here. Very nice. Very, very beautiful. This episode was rather shorter because, well, it's a simpler concept. It's just one single thing, one single addition to the system we already had. Next episode, what we're gonna do, we're gonna flip things around to make it more optimized. Right now, as it is, I think it should totally work on any app you run it, on any program you run it, like a game, I don't know. It should just find offsets fine. I think, I hope. But next time around, we're gonna flip it and we're gonna make it much more efficient. And you are gonna see how that works, essentially. I'll show you. I'll show you. You trust me, I know that. So yeah, this was the episode. Don't forget to overflow that like button, hit subscribe for more awesome content. There's a really awesome video on the way. I still need to make it, but it's gonna be cool. And yeah, pop down in comments below what you want to see. Maybe, I know it's rather a difficult subject, like a difficult example project, but if there's any particular way you want to scan stuff, pop it down. It's gonna be really awesome if you have any ideas you want to share. And yeah, thank you very much for watching. My name was Heap, yours was Undefined. See ya.